Hello, sound test. Okay, we have Rick's computer. No power, died on its own. Had it looked at by another store, and it said corrosion, but this has not been water damaged. It has been used in an office, so why there would be corrosion? Let's see. I think he said he brought it to London Drugs. They wanted 450 plus taxes and labor. Taxes, let's say that's 500. Labor, they're probably going to charge 150 for labor. 500, 650. Yeah, 650. 650. That's fun. Maybe I should charge more if the competition is charging 650. And 2 weeks turnaround. He brought this in on Wednesday. It's now Saturday. I totally forgot about it. I said I would have, no, now it's Sunday. I said I would have it done by Saturday, but it completely slipped my mind. Oh, let's, here's the serial number, 2017 model. I wonder if there's a program for video recording, since there will be lots of moments of silence. And if someone were to watch a video right in the middle and not know the context, it would be helpful to say, have like a piece of text that's always on the screen, kind of telling people what's happening, just to give them some context. But it would have to be like the person in the video would say it, and it would automatically be recorded or printed out in text on the video, instead of having to edit later. But I know that's so too fancy. Hey, they were right. This has been water damaged. Look at that. Okay, this is, yeah, okay, so they weren't lying. Red dot, red dot. I just disconnected the battery. That's the first thing to do. So this might not be fixable. Okay, well, like, this is total complete moisture, but it's funny. Wow, this is funny, because the board looks very clean. Who knows what it looks like on the other side, but the watermark indicators have been completely tripped. Not just slightly pinkish, but this is full red. So maybe the warehouse, the office that this has been living in the whole time, is very damp, lots of moisture. I wonder if this is the original battery. It looks a little different, but it's clean. It looks very clean. Okay, so it looks like this water No, he said there wasn't any water damage, and I believe him, but the moisture indicator are completely tripped, so that's it's a little confusing. Okay, so we're gonna take out the motherboard, the logic board, take out the fan, and check on the other side. Oh, you know, first thing to do is I'll do a quick power test. So I have a power supply here that will tell me how much current this computer is drawing, and it's fine to have it disconnected. Oh, this is completely dead. Completely dead. There's no light showing. Yeah. Wow. Dead. Oh, but that's because I don't have this cable. Without this cable, the light will not show up. This is the data cable. Still nothing. But let's try it with an original charger. That was just my bench power supply for testing, which it's very good at, but sometimes you need the original charger in really bad cases. And nothing. Okay, so actually this is very dead. Okay. Remove the keyboard connector. There we go. Keyboard backlight. There we go. A little sticky. Maybe there has been some water damage. Remove all the screws. It's what is it, 3 in the morning? Yeah. It's actually, this is a good hour to wake up. It's very peaceful, uninterrupted work. I think I will make this my daily routine. Hey, the monks, they wake up at 3. Wow. Yeah. London Drugs. London Drugs sometimes is more of a rip-off than Apple. I've been told by customers where they wanted just a simple battery replacement, and I think the quote was like anywhere at least 500, but more than that, more like 800 or something close to 1,000, because not just the battery, then they try to talk you into, oh, it needs this and that, the top case, the whole top case assembly, we can't just replace just the battery alone. And it's like, that's not a repair shop. That's like selling you half of a computer. Oh man. So thank God when customers come to me, my prices look really attractive. All right, take out the fan. There's 3 screws. They're all different, so you have to remember and not mix them up, because there's one screw where you could do some damage. It's nothing serious, but it's just a pain in the ass. Yeah, everything, every connector seems to be a little, has more resistance than normal pulling them out. I wonder if London Drugs actually took out the motherboard, or they just simply saw the red marks and just went on with their quote. I wonder if London Drugs even own a power supply, like a bench power supply. No, I don't think they do any board level repair type work. Just swapping out parts. But here we are actually gonna try to repair it. And if we can't repair it, I do have a replacement board. So, but always try to repair first. I'm a little slow today. Haven't done one of these in a while. Let's see the other side. Oh, it looks... So this is not a water damaged board. Not at all. It's super clean. Yeah. Look, there's no... Very clean. So, it's very perplexing. Maybe it's just a problem with his I/O board. What's the I/O board? This is the I/O board. It's just a board that has the charging port, USB, and headphone jack. They call it the I/O for input-output board. So we'll connect up that. We'll connect up the fan and see if it spins. I'm just gonna quickly connect it to my test power supply. No, it's dead. It's dead. I wish I could show you guys. Well, I could take this camera out. Oh man, not very much. Here, I'll show you guys. Let's see, webcam. There we go. You see that? Turn it off. And it's drawing 6 milliamp. 18.7 volt, 6 milliamps. It should be drawing 700 milliamps. So it's dead. And we are still connected. And there's no light. Very good. Very good. I don't like this camera mount. I should get a new one. Okay, that looks good. Go back to overhead. Alright, go back to overhead. Director. I'm a director and a repairman. Okay, so yeah, no power, nothing. Do we still... Let's check. Yeah, there should be no light. There wasn't light before. I don't think there should be. Sometimes, in a water damaged computer, the keyboard could be the only thing that is causing a problem. So yeah, so sometimes the board will work out of the computer. So it's dead. This is dead. Where shall we start? Okay. I don't like to use this one for testing since it's not covered. Not safe. Oh God. We'll use something with protection. Use this. Okay? And we don't need the fan right now. Just gets in the way. For testing, we don't need the cable Don't need the fan. Okay, just testing. Just testing. Okay, still at 6 milliamps. I think I know what the problem with this board is. They seem to, a lot of them seem to have the same problem with the capacitor failing. And in fact, one of these here, a lot of them I've seen come across have failed like that. So we got our multimeter. Let's measure. Okay. Do we have PP bus? No, we don't. Well, yes, we do, but it's not the right voltage. That's about 8.2. We should have 8.6. So what that means is our SMC chip, the power management chip, is not working. Okay, what can we do? It's not working. I really wonder. No, I think, no, this has been water damaged. Now I can see that clearly. Yeah, this has been water damaged. Well, it'll be obvious under the microscope, so. Someone has cleaned it, it seems. But they did a good job. Yeah, I can see. Oh, where's my micro? Oh, sorry. Wait a minute. I have something in. There we go. There we go. Okay. So I already spotted. Yeah. I'm sorry, but this has been water damaged. So Rick, he was not honest with us. Let's see. Okay, here's a bit of looks like wine. It's very red. Yeah, you see that right there. Yep. Let's see, let's zoom in. Zoom in. This, yeah, right here. Camera can't really see it very well, but there's a bit of something right here. So it's you know, but it's very little. So maybe the owner, it went unnoticed by him, but yeah, it could be a very small spill that went through the vent, and this is the back where the vent would be. And so yeah, you can see this area, this whole area. Okay, so it seems like our SMC chip is, well, it's not working, and maybe the chip is still alright, maybe it's just not getting power to it. The backside looks very clean. Yeah, very, very clean. And I'll show, this is our SMC chip here, and it looks extremely clean. So it seems like just that those two areas, those two chips, and really just that one chip is our problem. And this here, this is our chip responsible for the screen, for the light on the screen. And there is some signs of water here, so this usually gets damaged too, but in this case I think it's all right. Okay, so let's go back, and the one in question is this. What is that? So let's make a note. Let's go to our screen. Screen. Let's make it big so everybody can see. Bigger. Bigger. Oh, okay, this works. Yes, I do like this. Do like this setup. Okay, excellent. Yes, that will work. Okay, so we have the screenshot going. What was that? What was that other thing? Adobe. Okay. So we need to set up a file name. File. Open. (820.00165). This is what what? And we'll just duplicate. Dupe. No dupe. There's no dupe. Oh, there it is. Copy, rename. All right, let's call this something. Rick. Is there a name? Is there a name on the computer? Let's put down the phone number, maybe. Put down the phone number. 4226 4542. Water damage. 2017. Good. Rick. So it's this chip right here. This one. Okay, let's make a few notes. 6 milliamp. No power. Water damage. Rust here. Oh, let's PP bus 8.2, and we need 8.6. And this one rust here. This chip here is actually responsible for creating power, sending power to the SMC chip. Yeah, so let's search PDF. What is this one? Okay, so Let's see if we have the 3.42 power supply. That's important, yeah. That's a very important one. And yeah, that's right, because we are not getting light. Without this power supply, power rail, there will be no light. So most likely this power rail is missing. Very likely. Okay, so we'll go to our overhead. And what do we get? Ah, we do have this rail. This rail is present. So make a note. 3.42, okay. So most likely we're missing the output from this chip here. Let's see what the output of this screen. PDF. Screen. Search PDF. And number 5. So pin 5, R51, R5100. Where's R5100? Where's pin 5? There we go. So we can just probe pin 5 and see what we get. If I probe pin 5, actually over here there's, yeah, it's easier to probe this pin. So let's do that. Power's still on. Pin 5, yeah, we can probe it. So gonna probe this pin. And yes, there's our problem. Okay, I'll show you guys. I just probe. Okay, so go to overhead. Oh, but can I see without the, yeah, I can see. So we're looking for 3.3 volt and we're only getting 1 point something. Look at that, we're only getting 0.5, 0.6. Yeah, so this chip is bad. Let's replace it and I think that will fix our problem. Easy. Yeah, that chip is dead. So that happens quite often when there's power, when there's water touching electricity, touching a chip, it will short. And then after a while, when the water dries, it'll look clean, and you would think to yourself, hey, there's only a slight bit of corrosion, couldn't have done that much damage, but it did right when the water hit it. So yeah, I think this very easy repair today. Easy money, but lots of hours of study and experience in order to get this stage of easy money. Sometimes I spend like 2 days and end up not even being able to fix the computer, so it kind of evens out. Yeah, okay. Let's remove that and we should be done. Let's get the fan going. Okay, got the headphones on. Okay, what are we doing here? Let's see something so people can see what we're doing. Is that a good view? Is this a good view? Maybe we should get like a microscope view. Yeah, that's a good view here. And then what do we want to, we want to remove this chip. Okay, so let's actually first remove it from our donor board. We're gonna take it. Oh no, my fan. I need to fix my fan. Okay, give me a couple minutes. There's something stuck in the fan. My exhaust fan. Don't want to breathe in the fumes when we're soldering. Okay, let's resume our play here. Resume. Back to our normal programming. Hello? Hello? Yeah, audio's good. Let's see if the fan works. There we go. Good. So, we need to take it from a donor board. There we go. Is that what we need? Yes, that's what we need. Set this aside. Steal it from this one. Camera, yes, looks good. All right. Turn on our hot air gun, hot air station. Power. Wait a minute. I haven't soldered in a while. I don't know where all my supplies are. Okay, got it. Couldn't find the flux. Hey, where are we? This is not the right screen. You want to see the microscope view, okay? There we go. So we're removing this chip. This is what powers the SMC chip. So taking it from a donor board. There we go. Little flux to help. Speeds up the removal. Got our heat gun set at 430 Celsius and max airflow. This is the a1466 hot air station. I bought it because it's advertised as being 1000 watt, and it was about maybe $70 more expensive, but I find that the performance is the same as my cheaper one. I guess it is true that there's 1000 watt, but you never really use that much because you can't use more than 400, say 430 or 450 degrees. So even though you have that option of having more heat, it's completely useless. So really, you pay more money for a completely useless capability. The only thing different is that it has digital buttons, so you can, quickly press a button and it'll go to your desired temperature and stuff. But actually, I find that more annoying than just using the knob. The knob is faster. So in fact, I paid more money for features that I don't like. And it's all because I hear all these people on YouTube saying how good the hot air station is, and I was thinking in my head, yeah, 1000 compared to 580, that's almost double the power. It'll speed up my work, but really it's the same. Pathetic. I'll put a little flux on this resistor too, just reflow everything, just in case we'll remove it. Yep, there we go, it's off. Put the new chip on. Wait a minute. Yeah, is that right? Yeah, that's right. Oh shit. It went flying, and I don't know which one is the original and which one is the one that I want on it. Oh well, just put this one and see. Shaky. Very shaky. Must be doing some criminal activity. All right, there we go. That's good. Okay, so that's done. We'll cool it. Let it cool. Let's go to our overhead view. Use the air here to cool it. I think that's it. Just one chip. It didn't take too long. How are we doing for time? Almost 40 minutes. Not too bad. 40 minutes. But I don't know if that's easy. There's a good chance that the chip for the screen as well, for the backlight, is dead. That's a little, it takes more time to replace that one. Not much more. It's slightly more difficult. Okay, let's power it up and see. All right, so, but how can I show you guys? Let's attach the fan. Well, here, before I even attach the fan, let's just see what it's reading on the power supply. Nothing. Nothing. It's still the same. I don't think I removed the right chip. It's still the same. Yeah, I got the wrong chip. It's still 6 milliamps. I put back the original chip probably. What's our output now? Yeah. Oh, jeez. Wrong chip. But wait a minute. Maybe it's not the chip. Maybe it's not receiving power. Let's not be so hasty. So Screen. Okay, so 5 is our output, and we need, okay, so we need to measure pins 1 and 3. Are we getting power to pins 1 and 3? Yeah, that was stupid. I should have checked that before assuming that the chip was bad. Is bad or was bad? Is. Okay, so we need to check pins 1 and 3. Okay, so power's still on. Pins 1 and 3. 1. Okay, so 1 is connected to this resistor. Maybe one of the caps is blown and shorting. Oh no, we got, that's good. And pin 3. Pin 3. Do we have power to pin 3? No, so we do have power. No, I put in the wrong chip, I think. Well, we'll already check 1 and 3. SMC on off. Well, let's see what we get for 6 and 7. Maybe. Oh no, it's the chip. You see, the reason is because we are getting output to the chip. So obviously there's power because there's output, but the output is just low. It's not like there's no output. There's some output, but not enough. So that means the chip is bad most of the time. Okay. All right. I feel like I'm a beginner here. That should have been a very obvious thing to me. Okay, so let's go back, remove this chip, and put on the other one. You see, that was my problem. I should have, when I removed the bad chip, should have thrown it away so it doesn't get mixed up here. Okay, that's done. And here's our replacement chip. Oh, I'm so shaky. Oh my God. Please help me. Okay, it's on. Put some flux on and let it flow into place. Yeah, that's good, that's good. We're good. Okay. Let's study this. Let's study this schematic here. So we've checked 1 and 3. They're good. Did we check 6 and 7? No, I didn't check 6 and 7. Maybe 6 and 7 is low, are low. Yeah, why didn't I check? Oh, because. Okay. All right, let's go to the overhead. What do we get? Nothing, nothing. Still the same. Still exactly the same. This is bullshit. I thought it would be something very fast, and it's not. So let's see what we get for the output. It's still the same, still exactly the same. What's 8? What's 8 on this diagram? 8 is R reference out. 8 reference out. 3.3. Okay, pin 3 is good. So let's check pin 6 and 7. 6, 7. Okay, pin 7's easy to measure. Yeah, pin 6. Yeah, we're good. So what the hell is going on? So in fact, I'm confused. We have power to the chip. We have input signals. Oh, you know what that tells me? There's nothing wrong with the chip, but the output of the chip is shorted to ground. Ah, okay. So nothing wrong with the chip, but is what I'm thinking right now. So let's measure overhead. Let's measure the pin 5. Let's measure the diode. Take the diode measurement and see what we get for diode, and compare that with a good board. We get 416. That's not a dead short, but is it the right number? Is it TIA? Okay, this is a working board. So do we get the same? What was it? 416? Oh, way off. Look at this. On a working board, it's 806. So I think our SMC has been shorted and is dead. And it's shorting our output from this chip. Let's check it again. No, actually 800 is a weird number for diode mode. 537. Okay, now we have 537. It's cooled off. I think I got the probes on backwards. 800 is a very weird number. There we go. 5 something. 460. 460. I guess that's okay. It's off by a bit, but 420. 420 compared to 460. That's 40 points off. Yeah, that's a good sign that maybe it's the SMC. Okay, so let's go back to our screenshot. Go the output. Where does it go? Okay, let's look here. It goes to J61. Let's have a look at J61. No, J6100 looks good. So where else could it be shorted by? Well, there's the SMC, and that's a very high possibility. Or it could also be our... Are we at the screenshot? Good. It could also be our... Hey, I want this back. It could be our U7 1000, the charging chip, U7100, the charging chip. So let's have a look at that. Aha, there's a bit. You see, ideally, you want to replace the smallest, the cheapest, the easiest chip, and this would be the charging chip. But I don't know, it looks very clean. before you touch the SMC chip, which is a very it's a valuable chip. It's a hard to replace, hard to get. You can't get it new. So I wonder who is shorting. Who is shorting? Okay. Okay, let's go back to this. 3.2 SM6 and 7. Well, we got 6 and 7. But where does 6 and 7 come from? 6 and 7. Okay. 6. Okay. 6. Yeah. Wait a minute. I'm confused. I'm confused. It's like who's I don't know who's powering 6. Like, where does it come from? There doesn't seem to be an obvious power source for a 6. The signal. No. Yeah. SMC on off? Who provides? The SMC provides that. 6. Huh, okay. SMC on off. Oh, there we go. That's better. Yeah, it comes from the SMC. And the SMC is providing that. But we're 5 is low. Pin 5 is low. That's our problem. 7, that was 7. So who is responsible for 6? Six is also SMC. No, why is it keep clicking on 7? Okay, there we go. 6. Who is providing power to 6? Huh. I am confused. I don't know who's providing power to 6. Where does it come from? From the keyboard? What? Let's look at the keyboard connector. No, this is stupid. We are getting voltage. We are getting voltage on both pins, so there's no point. We shouldn't be checking. Getting voltages there. Let's go back. Should be faster than this. 6 and 7 are okay. We're getting voltages there, so let's not play with that. Three and 4, everything. You know, it just could be a bad chip from the donor board. Yeah. Yeah, let's try another one. It would be really like unlikely that 3 chips could be bad. So if we replace it with another one, and if it's still bad, then the something else is shorting that output from that chip. Okay. What? Looks like somebody removed this over once. What? That doesn't look right. That looks wrong. That looks very wrong. That looks extremely wrong. There we go. This is better. Okay, so what are the chances? Let's have a look at the SMC. Go to the microscope. Everything looks okay here, but you never know. There could be corrosion underneath. Damage could be done already, and it's not visible on the outside. But there's absolutely no corrosion on any of the test points. Let's assume the SMC is okay. Come on, let's replace this chip one more time, just to be sure, because it's a cheap, readily available chip. So it's wise to take that one first. Okay, good. Replaced. And let's remove it from our customer's board. Okay, that's out. Oh, so shaky. Okay. There, it sunk down. Very good. I have a feeling this voltage is still going to be the same. It's very unlikely that 3 chips could, yeah. The problem is somewhere else. Probably the SMC chip. Very likely it's a big chip with many pins, over 100 pins, and very easy for those pins to, if there was some kind of water, for those pins to get shorted to their neighbors. Yeah, that's fine. Let's power it up. You know, the best thing would have been just to take it from a known working board, but I didn't. Okay, got nothing here. You know, it could be our still the same. 6 milliamps, we haven't made any progress. This is stupid. This is extremely stupid. You know what I should do? Stop being stupid, man. What I should do is oh, well, it seems like we measured almost everything. except 4 and 8. Let's measure pins 4 and 8. Pins 4 and 8. Okay. Oh, I think we measured 8 already, and there was something. So pins 4 and 8. 4 and 8. Excellent. Let's see what we get for 4. Oh my god, it's over an hour. That's all right. An hour is okay. Pin 4, we got 2.75. I don't know if that's a normal number or not. So I will have to check 2.75. You know what? This is crazy. I actually have notes. I've made notes from previous repairs. So I always have like a reference notes I've made in the past. So let's go to my drive, go to computer repair, and this is, what is this chip? What is this number? U5100. Yeah, for sure I have notes for this one. So let's see, fine. Where's fine? Fine. U5100. Working. U5100. 5100. 5110. Let's make a note here. Output low. Output low. Only 0.5 volt. Huh? Where's my how come it didn't? Let me see. F U5100. Where are you? It should be here. You telling me I don't have, I've got nothing? I thought I got something. Maybe it's in my other notes. Let's do a global search. U5100. There we go. No, that's not really what, I don't want to find it there. Is it U50? Maybe I'm wrong, mistaken on U5110. Come on. U5110. Why are you not showing up? Okay, this is crazy. Okay, let's check it with a working board. See what we get for voltage. Oh. Okay. And what do we have? Can go back. Oh man, I hate this. This is too much work. It's too much work. I mean, doing the video recording and trying to work at the same time. Okay, so 2.77 is normal. I should make a note of that. Let's make a note of that. There's too many things going on. Okay, let's insert, okay. U5100, U5110, pins 1 to 8. Okay, and this would be diode, this is, and 2.75 is normal. And 3, 3, 3, 3 everywhere. Is that right? 3 everywhere? Is that correct? Let me check. Let me see. 1. Yeah, 8. Yeah. Oh, except for 2 and 9. 2 and 4. 2 and 9 and 4. 4, 2 is 0. There we go. So that's normal. Okay, what the hell is going on here, you guys? Problem. Okay, so we know that it wasn't that chip that was the problem. You know what? Let's remove the charging chip because it's easy to do so. Very easy to do so. 5. No, it's almost, seems like it's impossible because it goes through a resistor. Seems like it's impossible for that one to be shorted to ground. Even if it was shorted to ground, there's that resistor. So whereas, you know, the connection to the SMC is direct. And look here. Can you see? Let's go to screen. Can you see this is the connection to the SMC, and we've got like 2 grounding points right nearby it. So if there's anything in here from corrosion, it could bridge a connection and then short it to ground. So, but I still want to remove the charging chip anyways, because it's just easy to do, just to eliminate that. I don't want to touch the SMC. The SMC is a pain in the ass to reball and install. So let's do that. Can you guys see? Microscope. What are we at here for time? I don't even know, the time is hidden. see here. Come on, come on, come on. There we go. Good. It's off. So that chip is our charging chip. It's when you connect the power adapter, it provides power, the right voltage to the whole system. And it also charges the battery if you have a battery in there. So now we're gonna connect it, power it up, and if we still don't have the right voltage, then we know that the problem is at the SMC, because there are only 3 connection points. Okay, let's go back to our screenshot here. There's here the output. This chip is outputting that signal to the SMC, to the U7100 charging chip, and to this port. Is it called a port? Connector, but it's an empty connector, and sometimes in water damage this connector could be corroded and be causing a problem. But in our case it looks very clean, and it's a connector that's never used, so we can remove it just to be sure if we want. But in this case it's most likely not the cause, not the problem, so we don't need to touch that. So our other chips there are fine. Maybe we should save them. Okay. So now obviously without the charging chip there's no current being drawn. That's fine, that's expected. But this chip, this other chip that's providing power, should still be on. It doesn't need the charging chip for it to come on. So let's measure. And what do we get? No, exactly the same thing. So yes, the problem is with the SMC. Oh, hot diggity. Well, it's not so hard to put back the charging chip. So let's do that. Microscope. Let's reinstall the chip that we just took off. And make sure. Oh, okay, no problem. It has a pin 1 indicator, so we don't need to check. It's marked on the board where pin 1 is. We need to align it. Pin 1. Yeah. So there we go. So this is fine, just as expected, just as we suspect, because it looks very clean here, and also because it has that resistor. If, say, there was ever a short, that means the short has to go through the resistor, so there would never be like very high current to cause. That resistor most time will survive, so yeah. It's the SMC, but actually we should measure that resistor just in case anyways, just to be 100% sure. Man, this is taking a long time to heat up the solder. Very long. Okay, I just increased the temp by 10 degrees Celsius. That should speed things up a bit. Okay, set it down. Don't get so shaky, man. Doesn't have to be perfect. it'll slide in place anyways. Just so, can we be happy? Yeah, like that. And then it'll slide in place. Give it a bit more flux. And watch it slide into position. There we go. So it's good. Yes, it's very good. We're good. So actually what we need to work on is we need to reflow. Okay. Are we microscope? Let's go to screen. We need to reflow this chip. Well, all that means is we're going to heat it up, let the solder melt, and then hopefully it'll clean out some gunk underneath and it'll rebuild whatever loose connections there might be. Okay, so this is the SMC here, and it has some epoxy surrounding it that needs to be removed before we can reflow. There we go. Oh, that comes off nicely. The board is still very hot, that's why. Still got lots of heat, so just like butter. Okay, so this is our SMC chip, the System Management Chip, SMC. It controls all the power. It doesn't provide power, but it controls. It has sensors coming into it, keeping track of all the sensors. So how should we, let's point it this way so we don't avoid damaging too many chips around it. There we go. Okay, heat it up. There's still a bit of, didn't remove all. There we go. There was still a bit of that epoxy underfill. What are we doing? We're almost at 1 hour and 30 minutes. Okay. There we go. Got a healthy amount of flux on it. This stuff is very toxic, so make sure you have good ventilation. Don't try not to breathe it in too much. Yeah, okay. It just moved. I tapped it a bit and it moved. So it's that would be too easy if that fixes the problem. That would be way too easy. Because on the outside, there wasn't any sign, you couldn't see any signs of corrosion. Not in the test points, not anywhere on under the small components, the caps or the resistors, or even surrounding the edges, on the edges of the SMC. So, let's go back. Let's go back and study the circuit diagram here. This number 5 is our we're not getting the right voltage. It should be 3.3, we're getting 0.5. 0.5. Oh my god, I'm so stupid. You know what? Maybe the problem is I haven't checked. What about this resistor? Maybe this resistor's fault is off. I didn't even think to check that, but usually it doesn't fail like that, so but we can check that. That would be R5100. And where is R5100? It's down here on the SMC side. R5100. Are we still on the screenshot? Okay. So, oh, it's this one. Okay, let's check. Let's measure the resistance. We're looking for 100K. And it's reading 80, 81. But that could be fine because this is an in-circuit measurement. So it could be, the resistance could be dropped by parallel components. So let's just check it with, let's say check it with a known working board. And we should be what do we get? Oh no. I thought I saw 100K on the working board here. No, it's also 81 something, so that's normal. That's normal. Okay, in the meantime, let's continue on with making some notes here. So output is low. So use let me see, U7100 remove and okay, not cause of short. So SMC must be shorting the output. SMC reflow. Let's make a note. Pull up resistor on output. Okay. R5100. So the only thing left is the SMC. We just reflowed that. Now let's check it again. Let's power it up and see if there is any progress. Oh, there it is, there it is. There's progress. Okay, I'll show you guys. We made some progress. Oh, it's working, it's working. Okay, it is powering up. Okay. So that was the problem. It was just there was some corrosion on the SMC. So, okay, overhead. All right, I'm put on the. We can save those chips that we remove because they're still good. Maybe I should put them in Okay, look at this, and you'll see that there will be a light on it as well. Okay, turn this off so it doesn't, what is it called? Look, there's a light. I don't know if you can see it, and it spins. Okay, I'll do it again. I'll do it again for you so you guys can see properly. Okay, there's light. Okay, I just turned on the power supply. There's the light. It went green and then orange, and the fan is spinning. We're good. Solved. Problem solved. Happy, happy. Joy, joy. And so really, I did all that work when we could have just went straight to reflowing the SMC, but we had to check all those things. Fixed. So it took me an hour and a half. So altogether, putting it back 2 hours, and then we have to test everything. So let's say 2.5 hours. And let's save these chips. They are, I got a lot of them, but I still want to save them. I don't know why. I might be like wasting time here that I got so many spare of them. But at least I know that these are known good chips, so in a way these are better than just taking them from the board. Okay, let's put them in our inventory. Add it to our inventory of parts. That would be nice. That would be very nice. And what is the, maybe I have it already. Maybe I don't even need to add it to. Let me see. SN09 components. Fine. SN09 0903. Do we have that? Oh yes, we do. It's already, and it's bag 12, so we have that. I have an inventory for that already. I want to get rid of this bag and transition to the smaller bag. So bag 12. But then what will happen to all these small bags? Okay, got it. Yeah, and then where's overhead view, and okay, let's first, oh excuse me, hello, search, there we go. We wanna cut that piece. All right, cut it. Is this our white? No, that's not our white box. White, where's white? So 23, yes, and yes, okay, very good. So 23, bag number 23, 21, 22, 23, perfect. Excellent. Save these puppies. They're actually important chips because they are in an area prone to getting water damage. So it's good to save them. 23. Okay, so it's fixed. We're good. We can, yep, we can Okay. Put it back into the computer and overhead, we're good, and do some testing. Okay, here we go. That's good. Oh, I'm so shaky. You know, if that Nick guy without arms and legs could accomplish all that he has, then, you know, normal people like us shouldn't really complain with our minor flaws, and right? Yeah, like shaky hands. You can learn to deal with it, cope with it. All right. Okay, he also has Wi-Fi card. Where is his Wi-Fi card? What happened to his Wi-Fi? Here it is. Wi-Fi. Put the okay. Okay, that's good. Here's our input-output connector. Yep. Yep. Okay, we're good there. No, I don't want to put the screws in yet, just in case. Well, I'll put the fan screw back on. It's nice to have that held in place good. But the rest we can just leave for now until everything is checked and made sure that everything is working okay first. Otherwise it's a waste of time undoing the screws. It should be fine. Okay, so can I do this? So they wanted $600 to fix this. And what did they say? Like the board and maybe some other components will have to be replaced? Yeah, I guess so. They don't do this type of repair work. But well, two things. In water damage, the keyboard, it might be just the keyboard alone or just the logic board or both. Or sometimes even this I/O connector, depending on where the water entered. And that could cause it not to power on. Or sometimes just this cable. Well, no, actually the board should still be able to run without the cable, but if the connectors, okay? Sometimes the connectors underneath the cable could be bad. Look at that. Look at that. It's probably been a while since this computer has been turned on, so the battery's probably dead. Yeah, it's dead. So we need to plug it in. Plug it into the charger. Yes, yes, it's powering on. It's turning on. Very good. Wait. I don't have the login for his. I don't have. Oh, well, we'll just show so he knows that this is his computer. We'll just let it log into his computer once, and then we'll use my drive to do the testing. There's a little bit of a, looks like there was a piece of tape here before. Hey, the screen just flickered a little bit. Maybe that's okay. Okay, so what's the time? 1:37. 1 hour and 37 minutes. Hello? That's all right. This would make a good YouTube video, about 2 hour long. We can cut it short. We can just cut out the testing portion of it. Nobody need to see that, but we'll include it since the customer is also watching this. All right, look at that. And what does it say for the battery? It is showing that it's charging, but it's at 1%. Okay, so shut down, please, and put in a test drive. Oh, what is this? Software update? Oh, they got no, we don't wanna. Okay, it's off. Okay, unplug the battery. Don't forget that. Otherwise, if you start removing things and you got power going through the board, that's just asking for trouble. Gonna test it. We don't need to put the screw back on for testing. Okay, so just we're testing all the ports, Wi-Fi, Bluetooth, all the main functions. Oh, there's no battery power, no juice. Okay. There's oh, we need that. This is a 2. Okay. So, oh, it's getting warm. Getting sweat. Warm in here. So we want to test the keyboard, the webcam, USB ports, headphone jack, microphone, SD card, Thunderbolt, and speakers. Okay, so first thing I want to check is the battery, because in a situation like this, sometimes the battery circuit gets damaged, and even though this icon is showing that it's charging, and it's showing that it's charging here, but we always want to check. Yeah, so let's go back. Okay, it is indeed a 2017. It is his computer. Serial number should match the bottom plate. 2017 MacBook Air. Come on. Power. It is charging. There is no charge remaining. 370 cycle count. There's no charge remaining. So it's at 0%. Oh damn. The connector got pulled off, so whoops. I'm cold. Let's put on the heat. Testing. I don't enjoy the testing part. Maybe we can do this under 2 hours. That would be great. 2 hours. Okay, just we won't check the battery yet because it takes time to charge. Let's check everything else and then come back to the battery. Yeah, I was looking in my calendar and I have it marked Wednesday, 2017 MacBook Air repair. And in my head I was thinking, I don't remember collecting money for this. How come? Because that was the date that he dropped it off. And so I was supposed to have it done yesterday, Saturday, and I just remembered, and I was thinking about that. What is this? And then I said, oops, I forgot this computer. You should always mark in your calendar, not just the drop-off date, but also the day where you want to do the repair. Okay, so let's check the keyboard. It's 5 in the morning now. It's good, it's nice, very peaceful and relaxing. Okay, let's just check all the keys. Should be fine. Yep, we're good. Whoops. Function, yeah, we're good. Yep, F11, that's, yep. Volume, yep, that works. Yep, that works. Backlight keyboard, let's turn off the light. Oh, no backlight. Maybe I didn't connect it properly. Oh, that's fine. Maybe it just needs, remember, note to self, remember to check that. Maybe it just needs a PRAM reset or an SMC reset. The connector is a very simple thing. I don't think I messed up on the connector, but you know what? We could double check just to be sure. So we can't do a PRAM reset just yet. Okay, let's make a note here. Keyboard backlight. All right, and okay, so F11 is good. Power button, yep, it comes up, so that's fine. Everything's good here. Let's check the audio. Speakers. Here, speaker check. Here, you guys can hear it.
Portage makes every adventure count. It's just another Kia has you covered.
Okay.
Warning, this video contains flashes and moving images.
Left speaker. Right speaker. Good. Good. Okay. Let's check it through the mic earphone. Yeah, got sound. Got sound. Very good. Done. Okay. Check the microphone. Microphone, audio, sound, input. Yes, microphone works. Watch this. See that? Okay. So that works. Audio's good. Wi-Fi is good, obviously. We just checked that. Let's check the Bluetooth. Bluetooth. Do we have Bluetooth? Yes, we have Bluetooth. There. Okay. But you know what? Just because it shows up on the list doesn't mean should really connect it. Just to be 100% sure. Does my phone show up? Yes, it shows up. Connect. There we go. All right, we got the connection code. So that's good. So my phone I can use to always check the Bluetooth much faster than using the headphones. So that's good. Check the USB port. Oh my God. USB port. Oh, I'm worried about this battery. It's not climbing up the percentage. So if it doesn't charge, then we can do an SMC reset, PRM reset, and see if that helps. But it's a little worrying right now that it's not showing anything. Just okay. Okay. Yeah, that's fine. You can see that. Both USB ports are good. SD card. Yeah, SD card. It popped up. We're good. What else? Hey, that's all. Webcam. Why? Webcam. Webcam and... Okay, this webcam. Hello. And also the Thunderbolt. Okay, so you guys can't see it. Maybe I'll just show you over here. There we go. I'm gonna display it to this screen, okay? And you can also see the screen will flicker once it registers. Watch this screen. There we go. You got picture. So that's good. We're good. Okay, so the only thing I'm worried about. Okay, let me see. Make a note. So battery, and the backlight, keyboard backlight. We're getting nothing, but maybe it just needs. Okay. Maybe it's just the cable connection. It's still showing 0. It is showing that it's charging. Fully charged, no, but there's 0 charge to it. Oh, okay, it just went up to 1%. I hope you can see that. 1% now, so yeah, it takes time. Okay, let's log out, shut down, and check that keyboard backlight connector. And once that is done, is good, we'll screw it up, we'll screw in the back plate, put his drive in, and we'll let it charge, and that should be done. We should be done in under 2 hours. Remember, disconnect the battery. I make a point of that so that the customers can't blame me or say something, but obviously they won't blame me. I mean, I'll be giving them back a working computer, right? So if something's not working, then they can always come back for the warranty. No, the connector's good. I don't know what's going on. The connector's good. Yeah. Okay, we're gonna do a PRAM reset. and an SMC reset. So watch this, okay? How do you do an SMC reset? Oh, connect the power. I'm just gonna power it off. Hold it down to so it doesn't power up. Okay? This will change. Hold it for, okay? So watch, okay? So hold these 4 button key combinations for 10 seconds. 4, 5, 6, 7, 8, 9, 10. Once I release, the light will change to green. There we go. And then go back. So that's good. That was the SMC reset. Now we'll do a PRAM reset. Command Option PNR. Okay, let's turn it off. Power it up. PNR. Okay? Command Option PNR. That was one chime. We'll wait for the second chime. Second chime. Hello? There we go. See, did you hear the speakers got louder? So I think the backlight should be okay now. Guess that's what happens when the battery gets depleted all the way to 0. It loses the system memory, so it just needs to be reset, and that's why the keyboard backlight wasn't working. It should work now, I hope. It's not a big deal. Even if it doesn't work, nobody's really gonna care about that. Oh, unless it's a hardware problem and the backlight itself is actually faulty. Oh my god, it's not showing up. Damn. Maybe he's okay with that. Yeah, so the backlight, there's no power to the keyboard backlight. His backlight is no good. Huh. The keyboard is okay, but the keyboard backlight, you know what? Maybe it's a software thing. Maybe if I were to, you know what I'll do? I'll boot it from a different drive and see. I remember having the same problem on another computer and just, well, it was the Bluetooth not working. Okay, it's climbed up to 3%, so we're good on the battery. Let's, you know what? This port is not being very cooperative. Something's funny about, I haven't removed this. This is the I/O board, but it's totally crooked and it's, oh, sorry, I got a magnet on the, there you go. There was a magnet stuck to it. So I'm gonna boot it up from this external drive and hopefully that will, maybe it's just a problem with my internal drive and the Mac OS that I have. It doesn't like, and I noticed that this computer, it seems like, has been updated to the latest Mac OS version. So maybe there's a incompatibility issue. I was testing it with High Sierra and maybe he's got Big Sur and maybe that's too much of a gap. So we'll test it with Catalina. We are at 1 hour and 55 minutes. Okay, so to recap, everything has been tested good. The only thing left is the keyboard backlight. But it's such a minor thing. Even if, well actually, well, I could test it on my test computer to rule out whether it's actually the keyboard itself, or it's something to do with the logic board. Yeah, I could do that. Takes time. Not too much time. It's 5 a.m., 5:08. Got one job done. Gonna be collecting some money. That's good. Wake up to some money. What else do I have waiting for me? Kind of a fun job. Fun. You get to sit. You don't have to work your body too much. But maybe that's a double-edged sword. You become lazy. Get to listen to YouTube. It's fun. It's really fun job. Let me see Ethan. Okay. Ah, yes. I hope you can see that backlight, keyboard backlight works. So it was just a software issue, okay? No problem. So we're good. We're good in that department. So, okay, let's put his drive in there and go. Let's see. I can see it then. Okay. So, done, people. We're done. We're done. I'm just gonna let this charge. Oh, disconnect the battery. Okay. That's mine. Put back his drive. So everything's been, oh, don't forget. We still have many screws. All the screws for the board to put back. Okay, so let's, whoa. This is the hard drive screw. This is the heatsink screw. Tiny little heatsink screw. This is all the screws for the logic board. Come on, 1. 2. 3. 4. I'm gonna upload this. 5. There's one more screw. 6. Okay, so set it aside and let it charge. Okay, but just gonna quickly show you guys that it is running off of the battery, no problem. Okay. Everything's put back, correct? Yeah, we're good. Okay. Just gonna power it up. Okay. Very good. Very pleased with myself. Whoops. No. Yeah, we still have power. Oh, but maybe that's not enough juice. It chimed a little bit. Yeah, I guess not enough. Oh, it just takes time. Yeah, there's about 7% charge on there. Okay, so you guys seen enough. I can show it to you. Let's just put back all the screws and we can show it and we'll charge it. Put it somewhere to charge. Okay. So that was an easy repair. We removed a couple simple chips, and then the real main problem was just the SMC needed some reflowing. Yeah, it's really hard to tell. You can never tell with the naked eye that where the problem could be. That chip, the SMC, looked incredibly clean. So you would never suspect it to be the problem until you do some measurements and kind of narrow it down. These, you know, what makes it so difficult is Apple. They're being an ass. You know, they purposely use like these special screws that you can't just find screwdrivers for them easily. You can find them on Amazon and it's pretty fast. But if you say you want it done the same day right away after you spilled some water, well, you're gonna have to wait a day to get a screwdriver from Amazon. You can't really find it locally. I guess you can find like on Facebook, Craigslist, there'll be some people, one let's say, but still you have to wait. They may not respond back right away. So in that time, there could have been, you know, some damage done to the computer already when you have water in there and it's sitting with electricity, battery power still going through. So the damage will be done, and by the time they get the screwdriver, it's game over. So yeah, really all you need is just this one screwdriver, if that ever happens, to open up the back cover and dry up everything. Okay, so we're good, 8%. Done, very happy, pleased, extremely pleased. Let's log out.